Hey, fourth grade mathematicians, it's Miss Reed, although you can't tell because of the lighting. I hope you had an amazing Thanksgiving. I am here live with Mystery Monday in math. We're moving forward with our division, and today we are going to talk about factors. We're going to talk about prime and composite numbers, and we are going to make a list of factors in order from least to greatest. So at the end of the lesson today, if you can list factors in order of least to greatest, and you can use that list to tell whether a number is prime or composite, then you have been successful. But first, the moment you've all been waiting for, Mystery Monday. Ooh, take a look at this picture. This one might be easier than my other ones. Take a close look. I'm going to move you up a little bit. Ooh, zooming in. Take a look. What do you think that is? Think about it. For a house point, let's reveal. Flowers for you on your Monday morning. All right, let's move on to what we have at hand. Let's talk vocabulary. In math today, we're going to use arrays again. These are your objects that we put in rows and columns. Arrays often make counting and calculating easier. And today we're going to be some factor ninjas. We're actually going to build some factor rainbows today. And you're saying, what is a factor? We'll get to that in just a second. We're also going to talk about prime and composite numbers. We're going to use our factor rainbow to tell whether a number is prime or composite. Hold on. They decided to make an announcement. Yes, I am at school. Didn't you feel more like, oh, wow, when you heard that announcement? Okay, so factors. On here they have the number 24. Factors are the number you multiply together to build that number or get the product 24. A prime number only has 1 times itself that will make it, that will build it. And we'll go more into detail in a minute. A composite number has more than 2 factors. So prime has only 2 factors, which is the number 1 in itself that can multiply together to make it. And composite has more than 2 factors. Like the number 24 is definitely composite because I can multiply all these numbers to build it. Let's learn a little more of what I'm talking about through a short, quick video. Let's take a look. Keep watching. Not the ad.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct. Factors for the first time.
Yes, take a look.
In this short tutorial, you will find out what factors are and how to find factors using multiplication.
Pay close attention, you're going to need this.
Factors are whole numbers that you multiply together to get another number. So in this example, 2 times 5 is 10. The factors are 2 and 5. You will often be given a number and told to list all its factors. Well, you could just think of any numbers that multiply together to give 12 in this example, but a better plan is to use the same simple way every time. Take a look. The first thing you do is find the simplest way of multiplying to 12, and you start with 1. So 1 and the number itself are always the first factors you list. Write the factors down in pairs, 1 here and 12 over here. We will fill in the space between with other factors as we go along. For each factor pair, use an arc to show which factors multiply together. It helps keep your thinking clear and stops you from accidentally forgetting to write a factor down.
She's building the rainbow.
Okay, now you try 2 times number to make 12. Well, 2 times 6 is 12. List the 2 and the 6 and put the arc in. Then 3 times a number. 3 times 4 is 12. List the 3 and the 4, put the arc in. 3 and 4 are consecutive numbers. So we know we finished because there's no whole number between those 2. We've just found all the factors of 12.
Yeah, 3 and 4 next.
Notice that because we worked from the outside in, the factors are in order. This is the clearest way of showing all the factors of a number, and using the arc for each factor pair shows your thinking.
We call this the factor rainbow. We're going to be building lots of factor rainbows in the future, so keep paying attention.
We'll do one more example. We'll find the factors of 16.
I want you to try to do this with her. So start with 1 and think about 1 times what will give you 16. That's going to be the first arc in your rainbow.
Start with 1 and the number itself. 1 and 16. Use the arc. Now go to 2. 2 times number. Well, 2 times 8 is 16. What about 3 times number? Is 3 a factor? Well, 3 times 5 is 15. We can't get to 16. 3 is not a factor of 16. Now 4 times number. 4 times 4 is 16. When a number is multiplied by itself, like the 4 times 4, we just put it in the factor listing once, without any arc. And there are notes on...
No. All right.
What?
Did you see what she did there when it was 4 times 4? She only put it in the arc one time. All right, let's take a look at this quick video. Now we're talking prime and composite. How can I use my factor rainbow? See if a number's prime or composite.
Makes a square number is there. 1, 4, 9, 16, 25 can make a raise with 4 equal sides. 36, 49, 64, 81, just to name the first few of them.
A square number.
The product of a whole number with its number.
A prime number.
Even leave a visible 5, only one of its
A
numbers.
composite number.
Even leave a visible 5. Numbers other than just one and itself. When 2 factors are all you find, then that number's gotta be prime. They can be divided evenly by one and itself exclusively. Like the numbers 2, 3, and 5, they can only make a raise with the 1 on the side.
A square number.
The product of a whole number with its number.
A prime number.
Even leave a visible 5, only one of its
A
numbers.
composite number.
Even leave a visible 5. Numbers other than just one and itself. All composite numbers could be divided at least 3 ways evenly. The first composite number is 4. It's divisible by 3 numbers or more. The next of these are 6 and 8. They have at least 2 ways to make a raise.
A square number.
The product of a whole number with its number.
A prime number.
Even leave a visible 5, only one of its
A
numbers.
composite number.
Even leave a visible 5. Numbers other than just one and itself.
A square number.
The product of a whole number with its number.
A prime number.
Even leave a visible 5, only one of its
A
numbers.
composite number.
Even leave a visible 5. Numbers other than just one and itself.
A square number.
The product of a whole number with its number. Visit numberarc.com.
All right, they just threw a whole lot of numbers at you. So we're going to take a look at the meaning of all this. Let's see what they meant in those videos. Let's try it out on our own. All right, here comes our concept development. If you heard nothing else at the beginning of this video, hear this, because this is what your problem set is on and your exit ticket for today. So problem 1 says identify the factors and products represented in an array. So we now know that factors are numbers that multiply together, and a product is the answer to a multiplication problem. It's asking us to write a multiplication sentence that's represented by this array. So let me show you my trick. I start over on the left side and I count the rows. How many rows do you see? I see 1. So I'm going to put 1 times. Now how many columns do you see? 1, 2, 3, 4, 5, 6, 7, 8. I see 8. This array is built in 1 times 8. Do you see that? 1 row, 8 columns. And we know that 1 times 8 is 8, and that's how many are there. Let's look at this one. Let's go across here. First, your rows. I see 1, 2 rows, so I'm going to record that number. And now how many columns do I see in my array? 1, 2, 3, 4. And 2 times 4 we know is 8, and there are 8 there. So my number was 8. I arranged it 2 different ways in 2 different arrays. I can do 1 times 8, and I can do 2 times 4 and get 8. So because I can arrange it in 2 different ways, and because 8 right here has, let's see, it has the factor 1, has the factor 8, has the factor 2, it has more than 2 factors, so we would call this number composite, right? Meaning it can be built in more than one array. It doesn't just have 1 times itself. If it was 1 times itself, if that's the only way we could build the number, we would call that prime. But because we can build it like this, we call it composite. Let's look down here. Same thing that I just did. Factors and products. 1, 2, 4, and 8 are all the factors. See how they labeled them in order? You could do your rainbow, right? And our 2 and 4. If your factor rainbow has more than one arc, then it is composite, meaning we can find more than just one multiplication problem to build it. This is a composite number. All right. Notice that we also listed all the factors in order. Let's take a look at this next one. Ready? I want you to be thinking as I do this one, this is a lot of dots to count, right? What multiplication problem represents this? So start with your rows. Step one, how many rows? You're right, it's one row. So I'm going to write 1 times. Now I need to find out how many columns. I'm just going to put a dot above them because this is going to take me a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. We know that 1 times 18 is 18. This array shows 1 times 18. Let's look at the multiplication problem for this one. Start with your rows. How many rows? You're right, 2. Now, how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns. And that also equals 18. So this shows me 2 different ways to build 18. Now, if I asked you from looking at this, so what are the factors of 18? Here's what you would do. You would start here and you would say, well, 1 and 18 factors, right? And then you have 2 and 9 factors. I'm building a factor rainbow. And then we might say, I'm trying to see what color I didn't use here. I used blue. Let's use red. 3. Will 3 multiply out to 18 if I'm trying to find all the factors? If I want to know that, I'm going to skip count by 3 and check it. Ready? So let's try that. 3, 6, 9, 12, 15, 18. It does. 6 times. So 3 times 6 is also a factor, right? They're factors. Now, I have a 3 and a 6. The only numbers that go in here are 4 and 5. If I skip count by 4, am I going to hit 18? No. If I skip count by 5, am I going to hit 18? No. So look with my factor rainbow. I just listed all the factors of 18 in order. And I started it all with 1. And then I tested the numbers in between to see if they would work. So 1, 2, 3, 6, 9, and 18 are factors of 18. So because it has more than one arc on the rainbow and more than one set of factors, more than just 1 times 18, what do we call that type of number that has multiple factors, more than just 2 factors? Yes, we would call 18 a composite number. Composite. A good way to tell the difference between composite and prime is look at this, composite. And let's write prime under it. So I'm going to write prime. Which one is the longer word? Composite is the longer word. So that means it has more than just 2 factors. See all these factors? See all my arches? More composite, right? More than 2 factors. Prime is just a short little word, and it would just be a number that is 1 times itself, like the number 7. I can't build 7 any other ways. Just 2 go into 7, 3, 4, no. The only way I can build 7 is 1 times 7, so we call this number prime. And if I built a factor rainbow for 7, it would only have 1 arc on it. Do you see that? Multiple arcs, composite numbers. 1 arc, prime. Do you see how your factor rainbow can help you tell the difference between prime and composite? Okay, I want you to look at this one over here. Let's write a multiplication problem. We start with our rows, 1, 2, 3. So we have 3 times. We go down 1, 2, 3, 4, 5, 6. This is where they built that 3 times 6. That's 18. Look at all the different ways that 18 can be built. Definitely a composite number, right? Has a whole list of factors. Let's try another one. Ooh, this shows it in a picture of what we just did. Let's see. And it says when you get here, you notice your middle pairs and you say, well, what comes in between 3 and 6, 4 and 5, remember, and you can test those. That's how you know when your rainbow is finished. You look at your middle numbers. Are they close together? Did you try the numbers in between them? And then you're done with that. All right. This time they did 16. So somebody did an upside down rainbow, if you look at that. So if someone gave me the number 16 and they said, I want you to write the factors and all of the multiplication problems for the number 16, I would do this. I would start with 1 and 16. This is how you're going to attack your problem set. 1 and 16. And then I would say 2. Well, 16 is an even number, so I know that 2 is a factor of it. I can skip count by 2. 2, 4, 6, 8, 10, 12, 14, 16. I get 8 on my fingers, so I know that 2 times 8 is 16. What about 3? Let's test 3. Is 3 a factor of 16? If I did that, I would go 3, get my hand in here, 6, 9, 12, 15, 18. Nope, not going to hit 16. So I tried 3. What number comes next after 3? 4. Let's try 4. 4, 8, 12, 16. Yes, right? Because 4 times 4 is 16. Anytime I hit a number, though, when it multiplies by itself, it can just go right in the middle by itself, and I know I'm finished. Because 4 times 4 is that 16, I'm finished. Anytime you hit a double number, 4 times 4, right, equals 16. When it's double, that number times itself, it goes in the middle of your rainbow, and you're done. You're finished if that's a factor. So if someone then said, write out all the multiplication sentences that build 16, I would write 1 times 16, like this. I would write 2 times 8, which is this up here. And I would do my 4 times 4 equals 16. If someone asked me to list the factors in order, I can just put commas in my rainbow. Boom. It already lists the factors in order. Factor rainbow is the way to go. Now I'm going to ask you, is this number prime or composite? Give me a thumbs up if you think this number, 16, is prime. Give me a thumb sideways if you think it's composite. Your thumb should be sideways. Look at all the factors I have. When I have more than 2 factors or more than 1 arc on my rainbow, it is a composite number. So this is composite because I can build it more than just one way. I'm not just going to build it 1 times 16. If this was the only way I could build it, I would call it prime. But I can build 16 like 2 times 8, 4 times 4, right? So we call that composite. All right, let's try 1 times 7. Ready? Let's do our rainbow. Here we go. 1, 7. Well, if I skip count by 2, am I going to hit 7? 2, 4, 6. No, I'm not. 3? No. 4? No. 1 times 7 is the only problem that will build 7, right? So 1 and 7 are my only factors. It only has 2 factors. I call the number 7 prime. See how it only has 1 rainbow? See how it only has 1 multiplication problem? That is what makes this number prime. If I were going to build an array for it, the only way I could do that is like this. There's no other way to build that. Because if I tried to build it other ways, I would always have 1 left over. I can't divide it equally. So 7 is what we call a prime number. Numbers like 7, 11, right? All prime numbers. So it's different from 8, 10, 16, and 18 because it only has 2 factors. 8, 10, 16, and 18 have more than 2 factors. They're called composite. All right. I want you to think of right now in your head, can you tell me out loud a prime number? A number that's prime? Some people sometimes are like 15. Well, let's check 15. 1 and 15. Well, 2 won't do it because it's not even. 3 and 5, boom. As soon as we got that second arc, this is already composite, so 15 won't work. What about 17? 1 and 17. I could try to skip count by my 2's and get there. It's not going to get there because that's not even. 3, 6, no, 3 goes to 18, 4 goes to 16, 5 goes to 15. Hey, 17 is a prime number because there's only one way to build it, and it has 2 factors. So only 2 factors, prime, more than 2 factors, composite. All right, let's take a look at this. It wants factor pairs in a table for 35, and they want to know if 35 is prime or composite. So what am I going to build? A factor rainbow. All right, let's start with our factor rainbow. Ready? And my factor rainbow always starts with 1 and the number I'm talking about. So I'm talking about 35. You with me so far? Okay, if I skip count by 2, I'm never going to hit 35. And a quick way to tell that is 2 will only be a factor of even numbers. And 35 is odd, so 2 won't work. All right, if I skip count by 3, well, I know that 3 times 12 is 36. So I'm not going to get to 35. What about if I skip count by 4? 4, 8, 12, 16, 20, 24, 28, 32. Nope, it goes to 36. That's not going to work. What about 5? 5, 10, 15, 20, 25, 30, 35. Yes, 5 and 7. 5 and 7 will build 35. Okay, watch. So now I know that 5 times 7 give me 35. The only other number that's in between a 5 and a 7 would be a 6. If I skip count by 6, am I going to hit 35? No. So my rainbow is finished. How many arcs are on my rainbow? 2. That's more than one arc. How many factors are there for 35? Well, I have 1 times 35 equals 35. I have 5 times 7 equals 35. And I can put a comma between my factors. I have more than 2 factors. So this number is definitely composite. More than one arc, more than just 2 factors. It's more than just 1 times itself that will build it. I can build it 2 different ways. I could do 1 row with 35 in it, or I could do 5 rows with 7 in it. It would still build it. All right. Let's take a look. We are heading to your problem set. A lot of you, I hear, have been skipping the problem set. Have you ever heard that song, I'm gonna lose my mind up in here, up in here? Yes, I will. You need to do your problem set. You know what your problem set is. It's in your workbook. Today is lesson 22. You need to pay close attention to this because we skipped 2 lessons. We are on lesson 22 in your module 3 workbook. So you need to get that out. You need to pull out the problem set for today for lesson 22. It's going to look like a table. It's going to ask you to put in multiplication facts. It's going to ask you for factors. It's going to ask for prime and composite. You need to pull it out of your workbook. You need to complete it right now. After you complete it, you take a picture and send to your teacher. If you were skipping this step, your teacher is going to come hunting you down because now she's going to look for a picture of your work. And also you're hurting yourself. Because when we come back together and we pick up with this, we expect that you were doing this learning at home, you were in charge of your learning. This is super important. I can't tell you how much. And this is our first time on Prime and Composite. You need to be working on this. Now you're going to pause the video and do that problem set, take your picture and send it to your teacher. You will unpause the video when you're ready to check your answers. I'm about to go to the answer screen. So you should pause that video if you haven't done it yet. Doesn't make any sense to just copy down answers. You do no learning, and then you get to the exit tick, and we're like, oh no, look at this child. Didn't do any of the work. You got this. You can do this. Pause the video. Okay, friends, let me pull up our answers to our problem set for today. Let's take a look. Your problem set looked like this. We're going to look through your answers. Ready? I want you to check your thinking. Remember, this is the part where if this is hard for you, then I need you. Let's see if it'll give me a print layout. Let's see if I can make it bigger. If you find out that you had some trouble with this is difficult for you, this is the point in the game where you reach out to your teacher and you tell her, help me, please. Help me, please. It's not wanting to do a print layout, so we'll just go home. Make it as big as I can, but I'm going to tell you about it. We'll go through it. Ready? Okay. Let me pull you closer to the screen. Ready? This is like shaky camera. This is crazy. Here we go. The factors of 4 are 1, 2, and 4. You should have 1 times 4 and 2 times 2, and it is composite. You with me so far? I'm just going to pull this table up because that would be a little more ideal. Maybe you can see the numbers. All right, I'm going down the left side. 6. Multiplication for 6, 1 times 6, 2 times 3. Factors are 1, 2, 3, and 6, and it is a composite. Give yourself a check if you got it. Multiplication 7 for 7 is just 1 times 7. The factors for 7 are 1 and 7. That makes this a prime number. You should have a P over in the last one for 7. On D, multiplication sentences are 1 times 9, 3 times 3. The factors of 9 are 1, 3, and 9, and that makes it composite because it has more than 2 factors. On E, the multiplication sentences for 12 are 1 times 12, 2 times 6, 3 times 4. The factors are 1, 2, 3, 4, 6, and 12, and it is composite. On F, the multiplication for 13 is 1 times 13. The factors are 1 and 13, and that makes it prime because it only has 2 factors. On G, your multiplication sentence is 1 times 15, 1 times 15, 3 times 5. Your factors are 1, 3, 5, and 15. And that makes that, ooh, look guys, this is a mistake here. That should make that a composite number because it has more than 2 factors. So let's fix that on that. 15 is definitely a composite number. We're going to scroll down a little further. 16 on H, 1 times 16, 4 times 4, 2 times 8. The factors are 1, 2, 4, 8, and 16, and it is composite. On 18, it's 1 times 18, 2 times 9, 3 times 6. Your factors in order are 1, 2, 3, 6, 9, and 18. It is composite. On J, 19, your multiplication sentence is 1 times 19. Factors are 1 and 19, and it is prime. On K, it's 1 times 21 and 3 times 7. The factors are 1, 3, 7, and 21, and it is composite. On 24, it's 1 times 24, 2 times 12, 3 times 8, 4 times 6. The factors for 24 are 1, 2, 3, 4, 6, 8, 12, 24, and it is composite. This is the main work from the problem set that I wanted you to complete. If you had trouble with that, you please need to stop now and reach out to your teacher for help. If you feel really good about that and you did well with that, go on to the Google form for today. All right, guys, I'll see you tomorrow for, Tricky Tuesday.